Hey everyone, hopefully you guys made it to school today. I'm making this video before the snow is supposed to come, so I don't really know how much is coming. Anyway, obviously I'm not there today. You are going to complete the notes in class, follow along with this video, so the sub should be passing you out this set of notes. The notes should take you about 15 minutes or so to work through along with me as I do them. And then you'll get a review packet that is going to help you review for the test. The review packet, questions 1 through 23, will be due for your next class. So you'll have 1 through 23 to do for homework. Look back at your notes, hopefully go over some of those things to help you. I tried to break them up and do them step by step so that's easier for you guys to review. So if you have any questions, just email me. I'll be at meetings all day today, but if you email me or if something's not right or whatever, then hopefully I can answer those when I get a chance. All right, so here's the notes. If I go too fast, you can pause it and rewind it. But what I want you to do as you're taking these notes, I really want you to try to understand what it is I'm doing. Don't just write down what I write down. Try to make sense out of it and work through it before I actually do it. Okay, so after I do the example, try to do some of the practice problems and, pause it and then go back and check your answer and make sure you're on the right track. Just by writing down what I write down is not helping you. You have to try to make sense out of it. Okay, so we're going to factor by grouping. And we use factor by grouping when we have a fourth term polynomial, when our polynomial has 4 terms. So if you look at the one on the screen, the example, it has 4 terms. So we have to group the terms together and then we can factor out. So if you look, it says we're going to group the first 2 terms. So I'm going to put a parenthesis around the first 2 terms. Then I'm going to group the last 2 terms. So I'm going to put parentheses around the last 2 terms. And then I'm going to factor out any greatest common factors out of each of those terms. So x to the third plus 3x squared. What's the greatest common factor I can take out? This has 3, this has 2. So the greatest one I can take out is x squared. So I can take out an x squared. I'm left with x, because if I have 3 and I take out 2, I'm left with 1, plus 3. I already took out the x squareds so that I don't have any more left. So that's my first set that I factored. Okay, first group that I factored. The second group, okay, so I have a plus. I'm going to factor out what can come out of 2 and 6. So I can take a 2 out of that. And then I'm left with x plus 3. If you notice with this is the whole idea. The whole idea is to get this to be our common factor. Both of those should be exactly the same. When I take out the greatest common factor of both of our groupings, I should be left with exactly the same factors inside parentheses. That is my common factor that they both share, that both groups shared a common factor. So now I'm going to take that common factor and I'm going to write it out front. So we're going to write the common factor. Oops. So this part's going to say write the common factor. They both share out front in parentheses. Then we're going to put the remaining terms that are left in parentheses next to it. Okay? So if I look here, the common factor that I'm going to pull out is x plus 3. So that's going to go out front. Okay? Now what's left? X squared is left, plus 2 is left. So I'm going to put another parentheses, and I'm going to put those 2 together that's left. So I'm going to have an x squared plus 2. That's everything that was left inside or outside. Those are my common factor or my greatest common factors that I took out. That's what I took out. I'm going to put those together and put it in another set of parentheses. So my answer for factoring by grouping is that. So that's my final answer. Another thing that we need to look for, okay, is x plus 3. That cannot be factored anymore. X squared plus 2, can that be factored any lower? In this case, the answer is no, because x squared plus 2, it's not the difference of two squares, and it can't be factored anymore. So we're going to go down and we're going to take a look at number 1. So I want you guys to go ahead and maybe pause it, or maybe watch me do this one and then pause it and watch me go through some of the other ones, or try those first and see if you get the right answer. Okay, so factor by grouping. We're going to group the first two together. We're going to group the last two together. We're going to take out the greatest common factor out of each one. So in this case, x squared is my greatest common factor. I can't take out any numbers because they don't have any numbers in common, just x squared. I'm left with x plus 3 plus 5 and 15. I can take a 5 out. My greatest common factor is 5. I'm left with x plus 3. There's my factors again. They share x plus 3, so that was our goal. That's what we're looking for. We want it to get to having those factors be exactly the same. So now I can write my common factor, x plus 3 in the front, and then whatever's left, x squared plus 5, is going to go in the second set of parentheses. And now I'm going to ask myself, can x plus 3 be factored anymore? No. Can x squared plus 5 be factored anymore? No. That's already in lowest terms. It's not the difference of two squares. And so x squared plus 5 is the lowest it can go. So this right here is the answer that's left. All right. Number 2. I'm going to put my parentheses in the first set and my second set. I can't take anything out of 2 and 5, but I can still take an x squared out so that I'm left with 2x. Oops, let me erase that. 2x plus 5 minus, now this one is different, so I want you to put a star and pay attention to this one. This is minus, so remember, when we're subtracting, we have to distribute that negative to everything inside. So if I take out a negative factor, I still have to distribute that negative and take it out, okay? So my greatest common factor is 4. I can take a negative 4 out of all of that. So if I take a negative 4, I'm going to get 2x. And this right here is where it's going to change. It's going to be plus 5 because I took negative. If I have negative 8 divided by a negative 4, that gives me a positive 2. But if I have negative 20 divided by negative 4, that gives me a positive 5. So you have to think about those negatives. It's going to change the sign inside the box or inside the parentheses. Okay? So now I have my common factors. They're both exactly the same. So I know I can write that in parentheses out front, 2x plus 5. Write what's left, x squared minus 4. Can 2x plus 5 be factored any lower? Nope, everything's been taken out. 2 and 5 don't have any common factors, and there's only one x, so nothing else can be done there. X squared minus 4. Is that something that we've seen before? Yes, that is the difference of two squares. Remember the difference of two squares? Those were those special products that we talked about, the difference of two squares. So this is where we're going to have two more factors. So we're going to have, we're going to keep our 2x plus 5. And then remember, x squared is a perfect square, so I'm going to undo it by taking the square root of x squared, which is x. I'm going to have 1 plus and 1 minus because this is the difference of two squares. It does not have a middle term. Our middle terms cancel because we have one positive and one negative. So this is the square root of 4 is 2. So this is going to be x plus 2 and x minus 2. This is my final answer. So this is where we need to be careful when we're factoring these bigger polynomials, and we have to do it by grouping. We need to always make sure that the factors are in lowest terms, that they are completely factored. Okay, so that's why we're factoring completely. All right. Looking at your turn, factor by grouping. So what I want you to do is pause the video, and I want you to work through these. And then once you get to 4, go ahead and hit play and see if you got the correct answers. So go ahead and pause it, and then work through them, and then play it again. All right, see you back in a few. All right, so looking for the greatest common factor, you should have taken out n squared, and you're left with n plus 5, minus, you should have taken out 8, and you're left with n plus 5, because remember this negative and negative, we pull that out, we get, if we take a negative 8 out, we're going to have a positive 5. So then n plus 5 is our common factor, n squared minus 8. N squared minus 8, it's not the difference of two squares because 8 is not a perfect square, so there's nothing else we can do with that. So this is just your answer. Number 3, 5 and 8 don't have anything in common, but I can take an x squared out, so I'm going to take x squared. I'm going to get 5x minus 8. Minus, take these out. Now here it's a little bit tricky because this is still 5x minus 8, but I'm factoring out a negative 1. I have to take something out there. The only thing that I can take out is a negative 1. That's going to change my sign so that I get this to match 5x minus 8 and 5x minus 8. That's what my goal is, to get those to be exactly the same. Take out my common factor, 5x minus 8. Put together x squared minus 1. Now again, x squared minus 1, this is minus. X squared is a perfect square. 1 is a perfect square. So this is the difference of two squares. And so I'm going to have two factors. One's going to be plus and one's going to be minus. So 5x minus 8. X squared goes to x plus 1 and x minus 1. So hopefully you're catching on to those difference of two squares. We should be recognizing those by now. That's you have to look for two squares, and then if it's subtraction, then it's going to work. All right, number 2 down here. I can take out an 8, and I can also take out b squared. So I can factor out 8b squared. I'm left with b plus, if I divide 8b squared by 8b squared, I'm going to get 1. So it's going to be 8b squared times b plus 1. And remember, if we multiply this back, I'm going to get back to, I should get back to that if I multiply. So that you want to be checking that if you're not sure of your factors. You want to be checking and multiplying back to see if it works. Okay, minus, I can take out a 7 because they both have a 7. So I'm taking out a negative 7, and I'll be left with b plus 1. Okay, because of the negative, it makes it positive. I have the same factors, b plus 1 for both, so I can write that out front. And then I'm left with 8b squared minus 7. These are not perfect squares, so I don't have anything else to do with those. So there's nothing else I can do. So my answer is just b plus 1 and 8b squared minus 7. All right, the last one. The only thing I could take out is an n squared, so I'm going to be left with 7n plus 1, plus I can take out a 5, and I'm left with 7n plus 1 again. So then I have 7n plus 1 is my common factor, and n squared plus 5 is what I'm left with. And this is not a perfect square, or the difference of two squares, because it's not subtraction and they're not perfect squares. So this is your final answer. All right, so I hope that you were able to catch on to that pretty quickly, okay? It's a little bit easier. All you're doing is factoring out greatest common factors. You don't have to find multiples of anything, just like we were doing before. However, now we're getting to the point where we have to factor completely. So this is where we're factoring everything that we've learned so far. We're factoring them completely, we're putting stuff together, and we're trying to figure stuff out. So we're going to first, these are the steps that you should always follow. These are important. Okay, first you're going to look for a greatest common factor. Is there a greatest common factor we can factor out? If yes, factor it out and then continue factoring. Go to step 2. Look for special products. Okay, looking for the difference of two squares or perfect square trinomials. Those were in your notes. Go back and look at 7.7. Those were special ones that we looked at. The perfect square trinomial is a trinomial. The difference of two squares is what we've seen already up here. So you want to go back, if you don't remember what those are, go back at your notes at 7.7 and take a look at those. Then we're going to look to see, are we factoring a polynomial with 4 terms? If so, we need to do it by grouping. And then last thing is to solve, make sure all factors equal 0, then solve for the variable. If it doesn't equal 0, remember we have to move it to the other side so that we can make one side equal to 0 and we can factor the other. All right, so looking at the first one, number 1. First of all, is there a greatest common factor? That should be the first question. Yes, there is a greatest common factor. We can take a 2 out of each of those, and we also have an x to take out. So I'm going to take out a 2x. I'm left with x squared minus 5x minus 14. Okay, I'm not done. My goal is to factor completely. And so I have this trinomial right here that I still need to factor. So remember, we're going to follow the factoring rules for the trinomial. A times c, which our a is 1 in this case, so 1 times negative 14 is negative 14. And b is negative 5. So multiples of negative 14 that add up to be negative 5. So if you think about that, take a minute to think about it. You should have gotten negative 7 times 2 is negative 14, but added together gives you negative 5. So the factors, I'm still going to have my 2x. I'm going to have x minus 7, x plus 2. Since a is 1, I don't have to divide by a because it's just 1. And if I divide by a, it's going to be the same thing anyway. So I don't need to divide anything. And this is my final answer. Okay. Number 2. And again, if I'm going too fast, go back and look at it. Go back and review. Okay. So this one is a little bit different because now we have 4, our exponent is a 4, which we haven't seen yet before. We're still going to do it by grouping. So we have 4 terms. We're going to do the first 2 by grouping. The second 2 we're going to group. I can take out a 3, and I can also take x to the third out. So 3x to the third. I'm left with x plus 1. This is a subtraction, so it's going to change my sign inside the parentheses. I can take a 9, and also I can take an x out of both of these, so a 9x. So then I'm left with x plus 1, which is where I need to be. I need both of these to be the same. They are, so I can write my first factor, x plus 1. Whatever's left, 3x to the third, minus 9x, so that's what's left. Now if I look at this, can I factor that anymore? Is there more to factor out? If you look at it, I can still take a 3 out of both of those, and I can also take an x out of both of those. So I'm going to have x plus 1. I'm going to take a 3x out, and I have x squared minus 3 left. So now I'm going to rewrite this with all of my factors together. So I'm going to bring the 3x because there's nothing else to put with it out front. Then I have my x plus 1 and x squared minus 3. So that is your factor. So this was a lot of steps that you have to remember to do when we're factoring completely. Okay, so you have to make sure that you don't forget to add those extra steps in. All right. We're going to try this last one. So 2x to the third plus 8x squared minus 10x. First thing we look for, number 1, is there a greatest common factor? Yes, there's a greatest common factor. I can take a 2 out. I can also take an x. So then I'm left with x squared plus 4x minus 5 equals 0. So now I am solving. Okay, so now I'm going to look at x squared plus 4x minus 5. Can I take, can I factor that? And how can I factor it? So remember, we're still going to follow that rule where it has to multiply together a times c. So my a is 1. 1 times c is negative 5 to add up to be positive 4. What are factors of negative 5 that add up to be positive 4? So we have, this is, c is negative. Since c is negative, then we know we're going to have one positive and one negative factor. So my factors are going to be positive 5, negative 1. When I add together, I get positive 4. So I'm going to have 2x, x plus 5, x minus 1, and that equals to 0. Okay, I don't divide by anything because a was 1, and so there's nothing to divide. So now I can set each factor equal to 0, and I can solve for each factor. Okay, so 2x equal to 0, so x equals 0. If I subtract 5 from both sides, I get x equals negative 5. If I add 1 to both sides, I get x equals 1. So my x values are 0, negative 5, and 1. So those are my zeros, or remember, they could be the x-intercepts, they could be the zeros, we can call them, or your roots. So your roots or your zeros, those are 0, negative 5, and 1. Okay? All right, so that's pretty much everything. I'm not going to do the last couple problems. You guys can try them out to see what you get. But we're going to stop there. So hopefully this helps you work through your factoring completely on the review packet as well. Okay? So remember, your homework is only to do the homework or the review packet numbers 1 through 23. You should be able to get through most of that before the end of class, as long as you're doing what you're supposed to be doing. So hopefully you guys are preparing for this test. It's not going to be easy if you don't study. So good luck, do your best, and we'll come back and we'll finish the review in the next class period when I see you. Have a great weekend, and I will talk to you soon.